So today we're going to start our inverse unit. What does it mean to do an inverse? Find an inverse. Take the inverse. Okay. Inverse does not mean reciprocal. So if I have the equation, y'all, y equals sine of x. What is the reciprocal of that? Do you agree it's y equals 1 over sine of x? Which is, y'all are right, the cosecant. So what is the inverse? The other thing I hear a lot is, y'all are like, it's the opposite. Inverse is not the opposite. What is the opposite of y equals sine of x? That's if you negate it. Inverse is when you switch x and y. And so in here we would write like this, inverse sign. Or you're also going to see it as arc sign. Okay, those are the two ways. Do y'all agree? Y'all saw that in geometry. Okay, so let's talk about inverses because you learned about them in Algebra 2. I just kind of want to recap for this class. Do you agree in Algebra 2, let's just use y equals x squared because y'all know what that is. What is y equals x squared? What shape does that make on a graph? Oh God, thank God. Okay, y'all scared me for a second. Do you agree y equals x squared is a parabola? Okay, and so what does it mean to be a function? Passes the vertical line test. What's the vertical line test? When you draw a bunch of vertical lines and what happens? It only hits how many times? One time. Vertical line test. Y'all learned that like in Algebra 1, right? Okay. To be a function, every x only has one y. Now, to have an inverse, it needs to be something called 1-to-1. So you're going to see me, instead of actually writing out 1-to-1, you're going to see me just do that, 1-to-1. And in order to be 1-to-1, it has to pass the vertical line test and the horizontal line test. Do y'all remember that from Algebra 2? Does this pass the horizontal line test? No, because it hits twice. So I can change this function to make it pass the horizontal line test. How? Can I just restrict the domain so that x is greater than 0? And if I just showed this part right here, do you agree now it passes the vertical and horizontal line test? Right? And then y'all were saying earlier, inverse means to switch the x and y. So sorry, that was weird where I put the equals. Can I make x equal y squared? How do I get y by itself? Square root. And that's going to give me y equals the square root of x. What does that look like on my graph? Doesn't it look like a sideways parabola in one direction? Do y'all agree with that? Okay. So that is what we're doing today. But we're doing that with our trig functions. Now, we're going to start with cosine. Do you agree cosine starts at 1, 0? And then do you agree at pi over 2 it goes to 0, goes to negative 1, and then it goes back to 1. Y'all agree with that? And this is what we did on our test. Right? It's because my scale. I know, it looks ugly. Okay, forget that. Is this a function? Is it 1-to-1? Why not? Because if I do a horizontal line test, don't you agree I hit twice? So how far would I need to go in order to keep it a 1-to-1 function? Right here at pi. Do you agree right here, over here, I need to get rid of this because then it starts repeating? That is what we are doing today on this green paper. Do you see where up top it says the principal cosine function? This principal cosine function is going to restrict it so that it is 1-to-1. Right, Edwin? Yeah. So what I would like you to do is I would like you to draw. You can use your badge if you want to draw a straight line, and you're not good at tracing that. If you can do, this is going to be our y-axis, and here is our x-axis. And I'm going to plot the points we know. We know it starts at 0, 1, goes to pi over 2, comma what? At pi over 2, where does it go? To 0. And then at pi, it goes to -1. And that is my graph. What is my domain of this right here? 0 to pi. What is my range? -1 to 1. Do I have any questions so far? Does it make sense why I'm stopping right there? Okay, because I want to get the inverse. Now to get the inverse, what am I going to do? Switch x and y. So my new point is going to be 1, 0, 0 pi over 2, and -1 pi. Edwin, write this down. And I'm going to also switch the way that I number my x and y axis. So now my y axis is going to go by 3s. And my x-axis is going to be every other one. And what's going to be my domain here? And what's going to be my range? So your domain and your range are going to switch because we switched our x and y. I do just want to quickly show you this in Desmos. If you were to do less than or equal to x is less than or equal to pi, it will graph that first thing for you. Do y'all agree with that? Okay, and then if I wanted to graph the arc, what are they doing? Arc cosine of x, it graphs the other one for you as well. And for the arc cosine, it does do the principal function, the principal inverse cosine. What if I were to switch them and I were to write x equals cosine of y? Do y'all see how it does it sideways? But why doesn't this work? it doesn't pass the vertical line test. It's not a function. Does that make sense? Mm-hmm. All right, so that's why we have to do it the way that we did it. Okay. Let's do the principal sine function now. If I were to, where's that white paper? If I were to graph the sine function with y'all, like we've been doing, where does sine start at? 0, 0. And then do you agree it goes up, down, down, up, like that? Now with sine, y'all look up. With sine, where would I have to stop it so that it passes, it's 1 to 1, it passes both vertical and horizontal line test? At pi over 2, do y'all agree it starts repeating right here? So I would have to get rid of that. Well, that's not a full fine, like that's doesn't really do everything. So whenever we're doing the principal sine function, we're going to be going down and back to negative pi over 2. I know we never did that graphing. By the way, I'm not going to, except today, I'm not going to actually expect you to graph these. You are just going to have to be able to identify what goes with what. Okay? So let's graph that now. Sine always goes through 0, 0. So we're going to graph the origin right in the middle. And at pi over 2, what does it do? It goes up. And so at negative pi over 2, it's actually going to go down. And this is your principal sine function. What's my domain? Negative pi over 2 to pi over 2. And what's my range? And do you agree we can now graph the arc sine? Yes. All right, so switch your x and y, and please graph your arc sine, or your inverse sine. Now, how do we know which way to curve this? Cassandra, are you with me? I want you to think, if you were to turn this over, how would this curve? That's the best way I can do this, is I have to turn my paper, and if this was a sine function, how would I be curving it? That's how you kind of know which way it's going to go. And then again, your domain and range do what? Is anybody absent? Jayla and Kai. It's Jayla's birthday today, too. All right. So your first quiz, which I told you on Monday, is I'm going to be giving you the functions, and you're going to have to identify which graph goes with which. How would we be able to tell? How do I know, if just by giving these curves right here, which one's sine, which one's cosine, which one's arc sine, which one's arc cosine? Where they start at. So you're still going to look at that. Where does cosine start at? You're going to look at the y-intercept. It starts at 0, 1. For arc cosine, what are you going to want to look at? Instead of the y-intercept, look at the x-intercept. Where does this x-intercept at? 1, 0. That'll be a big tell. Alright, if you can identify, tell those apart. Also, your x and y axis will be labeled, so you'll know, hey, that's not how my, that's, you know what I mean? For sine, again, it goes through the origin at 0, 0. And inverse sine also goes through 0, 0, but you need to pay attention to the x and y axis. And that's how you can tell those apart. Okay? Do I have any questions so far? Let's think about tangent. Your regular old tangent parent function. Is it 1 to 1 already? Yeah, so I'm just going to graph the tangent parent function right here. Because tangent's so sweet, it's already 1 to 1. What is my domain for tangent? Negative pi over 2, 2. But how is it different than sine? Has asymptotes, so what do I need to do? Nope. Instead of brackets, what do I need? Parentheses. These are going to have parentheses instead of brackets. Over there, it does equal pi over 2 has a bracket. This is an asymptote, it's going to have parentheses. What's my range? All real numbers. So how am I going to do the inverse of this? He emailed me already. How do I do the inverse of this? Asymptotes where? On the y, they're going to be horizontal lines now. 1, 2, 3. At pi over 2, I'm going to draw a horizontal asymptote. At negative pi over 2, and then it's going to go through 0, 0, and it is going to be positive. I'm not very good at drawing this sideways. Do y'all feel like you'll be able to identify the tangent and the inverse tan very obvious compared to the other ones? So I'm not too worried about those two. And again, what happens to my domain and range? My domain now becomes all real numbers, and my range is that. Please write that down. I know this is not the most exciting lesson. The good news is that's going to be the last time you have to graph in here until December. Wake up. Yeah, you can stand up. I can get you a clipboard. You want to stand up at the back? All right. So, quiz A on Monday is basically going to list A through, there you go, Kai. I'm going to list answer choices A through, I don't know, F or something. I don't know what it is. And it's going to have cosine. And you're going to have to find the picture, the domain, or the range of cosine. Of inverse cosine. The picture, the domain, or the range of inverse cosine. That's all it is. It's just matching. Now, I'm making it sound a little bit easier than it is because you're not finding all three. You have to figure out which one is there for which. But this front of your paper is what you should study for your quiz on Monday. And again, I'm going to give you a little time to study when you walk into class. Okay? But any questions on inverse cosine? Okay. Yes, the principal cosine. Yes. Yep. All of it will be like this. The quiz is just matching. Matching. 6 questions. Matching.
What?
Letters. Yep. Matching. I am a little bit. Yeah. It's not the best quiz in the world, but yeah, I am. All right. Y'all ready to go on? Because your favorite thing ever is on the back of this paper. Please turn your paper over. Okay, you can't forget anything. I need y'all to brain dump this unit circle at least one time this weekend. All right, one time in the whole weekend. I just need you to, because some of us have already forgotten it all. And that's going to be an issue because this whole unit involves this unit circle in detail. So, just right now, let's brain dump the first quadrant. Okay? So, and we're going to do radians. So, what is 0? Then we have, what comes next? Pi over 6. Then we have pi over 4. And then pi over 3. And last, pi over 2. Cool. First quadrant. Are we okay with that? Okay, now let's talk about the sine and the cosine. What is my cosine of 0, 1? What's the cosine at pi over 6? 3 pi over 2 is wrong. Square root of 3 over 2 is correct. What about pi over 4? Square root of 2 over 2. Please write this down. Pi over 3. Is it coming back to some of y'all?
Yes.
And pi over 2. And if we're being honest, y'all probably liked writing it the other direction. So I'll start at 90. I'll start at pi over 2. What is the sine of pi over 2? The sine of pi over 3? The sine of pi over 4? And the sine of pi over 6? And the sine of 0. What questions do I have? We awake? Barely? Barely? Okay. Tangent now. What is the tangent of 0 degrees? Ooh.
0.
Think about slope. What's the slope of this line? 0. And I'm going to box our tangents just so they're easier to find. What is the tangent of pi over 6? And everything we're going to be doing this unit, let me double check and make sure. Yeah, everything we're going to be doing this unit is going to be in radians. So a trick you can remember is 3 plus 3 is 6 to tell you, remember which one tangent goes to. What is the tangent of pi over 4? We like that one. Tangent of pi over 3?
3.
And then what is the tangent of pi over 2? Undefined. Are we okay? Okay. So, why do we have the unit circle in front of us, and what does this have to do with anything? We are going to inverse it. So what does it mean to inverse it? Normally, hold on, last unit, you were taking the cosine of a theta, and you are giving me the x divided by r. Do you agree? The cosine of pi over 6 is square root of 3 over 2, right? This unit, you are going to give me the inverse cosine of x over r, and your answer is going to be a theta. Can you write that down at the top of your paper? Come on, Nicole, write it down. I know. The cosine of theta is x over r. The inverse cosine of x over r is theta. So now, instead of me asking you, hey, what's the cosine of pi over 4? I'm now going to ask you, where is cosine square root of 2 over 2? I am asking you backwards. So, can I change this? Are y'all cool with that? So on the bottom, I'm just going to do some example problems. These problems I'm giving you right now, this is what your quiz B is going to look like. So number 1, what is the inverse cosine of square root of 2 over 2? Where is cosine the square root of 2 over 2? Pi over 4 is my answer. So where is your x square root of 2 over 2? Pi over 4. Let's do another one. Over here. What is the inverse sine of 1/2? Where is your sine? Where is your y? 1/2. Pi over 6 is the answer. Does that make sense? I want to make sure I'm doing the same examples. Last one for like this. What is the inverse tan of the square root of 3? Where is tangent square root of 3? And that's your answer. We are working backwards. Your answers should all be a theta, a radian, pi over something. Okay? Now, that's just if it's in quadrant 1. That's only if it's positive. What happens if it's negative? I want everybody to go back to your front paper. And I want you to look at your answer, your rise, your range for inverse cosine. What is your range for inverse cosine? 0 to pi. Do you agree 0 to pi is from here to here on your unit circle? Do y'all agree with that? What quadrants is that on your unit circle? Not in this picture, on your unit circle. Quadrant 1 and 2 is going to be where your answer for inverse cosine. Does that make sense? Okay. So, I'm going to flip back. We now need to do quadrant 2. Oh, hold on. Let me flip back over. Sorry. What about inverse sine? Negative pi over 2 to positive pi over 2. Do y'all agree negative pi over 2, if you're going backwards, it's on the bottom? To positive pi over 2, what quadrants is that going to be on your unit circle? So for sine, we are going to be in quadrant 1 and quadrant 4. Sine is in quadrant 1 and quadrant 4. And last but not least, what about inverse tan? Negative pi over 2 to pi over 2. Same thing. Negative pi over 2 to positive pi over 2 is quadrant 1 and 4. Now some of you are like, Miss Olivares, there is nothing in this quadrant 4. I'm not talking about this picture. I'm talking about on my unit circle. On your unit circle, if you were to go negative pi over 2, do you agree that we end up right here? And then negative pi over 3, negative pi over 4, and pi over 6. Do y'all agree with that? Negative pi over 6, sorry. Yep, write that down. So what's going to be in quadrant 4? inverse sine, and which other one? Inverse tan. What's going to be in quadrant 2? Inverse cos. Now you're probably like, Miss Olivares, why is that negative pi over 6 and not 11 pi over 6? Right? On our old unit circle, didn't we learn that was 11 pi over 6? But on this graph right here, do we go all the way to 11 pi over 6? No. So 11 pi over 6, 5 pi over 3, 7 pi over 4 will never be our answers. It will be these. Okay? Let's do the second quadrant real quick. This is 2 pi over 3, 3 pi over 4, and 5 pi over 6. What is my cosine of 2 pi over 3? Negative 1/2. And we're not going to worry about the sine because inverse sine is not in this section. So I put a big X. Write it down, please. What is the cosine of 3 pi over 4? Negative root 2 over 2. We're not going to worry about that. And then, why are we not worrying about these signs? Because one, my inverse sine graph doesn't go over there, right? But also, what do you notice about these sine values? They're the same. And remember, it has to be a function. Every x needs only one output. If we were to include these, that would give us two outputs. How would we know what we were talking about? So that's why we're not including these. And this one is negative square root of 3 over 2. Last but not least, we need pi. What is the cosine for pi? Negative 1. All right. Get ready to see some examples? The examples help to put it all together. Without them, it's confusing, in my opinion. All right. Right here, number 2. What is the inverse cosine of negative 1? Where is cosine negative 1? Pi. That's your answer. You all ready for another one? What is the inverse cosine of 1/2? Where is cosine 1/2? Okay, positive 1/2. Pi over 3. Now, today, tomorrow, I'm cool with you looking at this unit circle for help. It's the first time we've seen it in 2 weeks. I get it. Starting next week, you got to get rid of looking at this because you're not always going to have it. Okay? Last one for cosine. What is the inverse cosine of negative square root of 3 over 2? Where is cosine negative square root of 3 over 2? Where is your x negative square root of 3 over 2? What? 5 pi over 6. What quadrants do we deal with cosine? Quadrant 1 and 2. Oh, inverse cosine. Put a little inverse on that. Don't forget your negative 1. What questions can I answer? Did I go too fast on that? A little bit? Can I clarify anything for anybody? This whole column is where's your x, that number. Give me that theta. All right. So quadrant 4, we already talked about it. Sine and tangent are in quadrant 4. So I'm not going to have a cosine value at all. We already did those cosine values up here. So I'm just going to put an x where cosines are because I'm not going to have one of those. I'm not going to have anything there. What is the sign of negative pi over 6? And it reflects from above if you need help. Negative 1/2. What's the sign of negative pi over 4? And the sign of negative pi over 3? And the sign of negative pi over 2? Let's see if you can do these on your own while I walk around and help some of y'all. See if you can find the answers to those. Yeah, I think I saw in the weather it's going to start being in the 60s finally, in the morning at least. Where is sine square root of 2 over 2? Pi over 4. That's our answer. Where is the y square root of 2 over 2? Where is sine 0? Ooh, sine. What sine? Your y. Where is y 0? 0. How come we're not putting pi? How come we're not putting pi? Huh? Sine is not in quadrant 2. Where is sine at? Quadrant 1 and 4. And then last but not least, what is the inverse sign of negative 1/2? Negative pi over 6. So this right here for sine inverse is quadrant 1 and 4. Alright, last one we're doing today is tangents. Let's just write it on our unit circle. What is the tangent of negative pi over 6? Tangent of negative pi over 4? And tangent of negative pi over 3. And actually, we don't need to do the undefines because do y'all agree over here it has the parentheses? It's not equal to. I won't be asking you those. Okay, did y'all get those tangents? Yeah. And then here, let's do 2, 3, and 4. What is the inverse tan of negative 1? The inverse tan of 0. And the inverse tangent of negative square root of 3 over 3. Answer those 3 questions, please. Is this making sense? This is your quiz beat. And the quiz beat is next Wednesday. Easy to do when the unit circle's in front of you. What about when it's not in front of you? Okay. Where is tangent -1? Negative pi over 4. Where's tangent 0? 0. And where is tangent negative square root of 3 over 3? Bam. Alright, thank y'all for hanging on, and I know it was a rough one today, but we are done. Tomorrow we're going to do reciprocals. Quadrant 3, what happened to quadrant 3? Nada, we don't use it. We're not using quadrant 3 at all. Because on here, we never go from pi to 3 pi over 2. Because that's what quadrant 3 is, right? Pi to 3 pi over 2. On these graphs right here, because remember we want it 1 to 1, it's never going to go over there. Yes, to what? The bottom? There you go.